Well, while you guys join, let me start a little bit. Good afternoon, good morning, or good evening to you guys, wherever you guys are. Bob, you can start sharing the presentation so I can take control for a short while. Okay, request remote control. Here we go. See if this works today. My internet connection here is not the best. I'm in the GMI Dubai office, and I've seen that things are not as, as per European standards. Anyhow, so guys, again, welcome. Welcome to the Understanding Wall Chart, basically Fundamental EX webinar today. Before I start, let me introduce Bob. Some of you may know Bob. He's been in the industry for over 30 years through his company, which is Source IEX. And he is a very competent guy because he's a Comp EX instructor as well as an instructor for the ICEX Comp PC scheme. He's also a member of the US UL STP committee, and he's an inspector. So he's done a lot of inspection on the field. So part of the presentation also comes from his experience. He's very qualified to run the webinar today. But before I let him do that, I need to take a few moments to talk to you about GMI, what we do, why we do it, and why we're here today to do this webinar. And we like to transfer knowledge, but at the end, we are a manufacturing company. We design, engineer, and manufacture a complete range of intrinsic safety and SIL certified devices, such as barriers for all automation packages, DCS, ESD, fire and gas, SCADA, and so on, supplied in all industrial sector, primarily to oil and gas, but also pharmaceutical, food and bev, and so on. We have over 40 years of experience, and we're very proud to manufacture our product in Italy. So we have 100% in-house production. On the other hand, we are a good global player with presence in all the continent. Because we make safety products, safety is our priority, so we try to make very high quality product through state-of-the-art technology we use. We have some patent ideas. We do have 100% product traceability, so we know the history of that components that you might get one day. We do 100% testing on each single device, full testing. All the testing are recorded, so one day from the serial number we can go back to that test data. Of course, we are ROS and REACH compliant, and we are SIL3 or Systematic Capability SC3 certified as a company for functional safety management. So we can manufacture a SIL3 product. And our responsibility, social responsibility, means that we're trying to have a better world we live in, better product, safer plant, better place for us all. These are the products we manufacture. So we have intrinsic safety barriers, safety relays with and without line monitoring. We also have line of SIL certified isolators and power supplies. We also have multiplexer, temperature multiplexer, digital multiplexer, hard multiplexers. We have a complete line of termination board to interface most common system out there. We supply surge protection device or SPTs, loop indicators, and we also doing a functional training and EX division. It's through this COVID period, which I hope you guys are managing through it. We are doing a little better in Italy. I'm here in Dubai today, and not as good as Italy. Still a lot of limitation, but still we are now trying to provide these services online. And we have offices around the globe. We have many distributors. We are about 200 people, and we do have thousands of installations around the globe. These some of our customers, system vendors such as ABB, all the way to Yokogawa. We have done many projects with many EPCs, and we supply our product to OEMs such as rig operators, skid manufacturer, wellhead packages, gas turbine, and so on. And we are the AVL of many end users, especially in the oil and gas. I believe that's it. Now is in the hands of our professional speaker, Bob. So I'll let you talk. Let me release control here for a second. Give up remote control. I will be in the background. Before I let him start, I'll remind you that you can get in touch with us through question and answer box. You can type questions. We'll try to answer them. We also have prepared a question and answer presentation at the end of this webinar, which came from the questions you posed during the registration process. Okay, Bob, it's all yours. Thank you again. I'll be here listening in.
All right. Thank you, Paolo. And thank you all for joining us. Paolo, can you mute yourself a little bit? I hear a lot of feedback.
Okay.
Just a little. There we go. Thank you. Well, good morning, good afternoon, and it's a pleasure to be here today. So again, it's early in the morning here in Houston, Texas, but we'll try to get through this. There's a lot of information that we're going to talk about, and the last time we did this, it ran a little bit long, so we'll try to keep it to an hour. We might be an hour and 5-10 minutes or so, but we'll try to get through this information in a pretty quick time frame. Let's see if I can do it. Yes. So EX wall charts. These are wonderful tools. You see them, you may have them. Lots of manufacturers and organizations such as certification bodies give these out all the time. And every time I go and visit a customer, I always like looking at them just to kind of find out what's on them and how customers use them. And I always ask customers, I say, hey, what do you use this? And sometimes they say yes, sometimes they just say, no, a vendor came on over and gave it to us. So I kind of thought it might be good to have maybe a review or an overview of these wall charts and what information is here so you can use them in a more expeditious manner, so to speak. So there's a lot of information. Every wall chart is different. So I'm going to use, in effect, the GMI wall chart that we give out. So there's, again, wall charts are fantastic, but do understand as soon as they get printed and they get published, they have a tendency to go out of date in a fairly quick fashion. So this one is fairly up to date. And we're going to go through the various sections of the wall chart, and then we're going to talk a little bit about some of the EX marking of equipment, because that's usually a question that really confuses a lot of people. So we'll spend a little bit of time at the end going through some of that information. So looking at our wall chart, the first thing we need to understand, if you will, is area classifications. And this part of the wall chart, the area classification information, is located in the top left-hand side. In the international community, we classify areas based upon two specific standards in the 60079 series. 10-1 is our area classification for gases and vapors, and 10-2 is for hazardous dust. Now, there are some other international standards and standards that we use here in the United States that will also be very handy guides, if you will. The Energy Institute IP15 is a very robust document. Many oil and gas companies use this document for area classification. And there is some similarities between what you find published in the Energy Institute as well as the 60079 standards, but they are different. But there are a lot of similarities and some generalities, which we'll kind of focus our attention on. We also have what is called API recommended practices for the United States in 500 and 505. And we also have a document called the NFPA 497 that is widely used here for area classification in the United States. So when we look a little bit further on our wall chart here, notice on our left-hand side, we have protection levels very high, 2 independent means of protection, which allows 2 independent faults. So that particular protection level is the highest level of protection. It's for use in an area in which an explosive atmosphere is frequent or for long periods or continuously present. For gas hazards, we would consider that to be a zone 0 environment. So think of a zone 0 inside of a storage vessel that may be containing some flammable liquids. The area right above where the liquid is where the vapors would be located. That would be normally considered to be a zone 0 environment. On the top of those columns there, you'll see the 99/92/EC. That's ATEX for employers. That has to deal with our area classification. So it is a responsibility under the ATEX directive for the clients to go ahead and make a determination as to what areas within their process facility should be classified. And again, we use the 60079 standards. The categories are what you see on the right-hand side at the very top. You'll also see a 2014 34 EU. That's ATEX for manufacturers. So once we've determined our area classification, then we have to determine, is the product suitable for it, and how are we going to mark this product? And then on the far right-hand side, under the IEC Ex scheme, we have what are called EPLs. But going back to on the left-hand side, for mining applications, which is something that we don't typically run into, anything below ground would be a Group 1 environment. Anything above ground, a surface industry, would be a Group 2. And then we find that we have surface equipment groups under the ATEX directive 1, 2, and 3. We can also find G or D. Those stand for either gas or dust hazards, and so forth and so on. So the important thing to remember from this point is, again, understand that equipment that has high independent means of protection is suitable for zone 0, which zone 0 is an area in which it's continuously present. A high, which would be a single fault and still provide safety, would be suitable for environments in which gases are occasionally present during normal operation. We would consider that to be a zone 1 area. And then finally, a product that doesn't have any fault level protection, but is safe during normal operation, that product would be suitable for an environment in which a gas, vapor, or dust hazard is not present during normal operation. But if it will be, it will only be for very short periods of time. So think of it this way. Very high would be a zone 0, a high would be zone 1, and normal would be zone 2. So I just mentioned this already in my slides here. So again, a very high protection level would be very high fault tolerant. And again, under the ATEX directive, it references equipment categories, where under the IEC Ex, it references equipment protection levels. So categories and equipment protection levels basically mean the same thing. So when we talk about a 1G environment under ATEX, under IEC Ex, this would be considered to be a GA. If we talk about 2G under the ATEX directive, that's equivalent to IEC Ex GB. And then finally 3G, that would be equivalent for GC applications. So now we understand a little bit about zones. This should hopefully give us a little bit more understanding of what we have to put on our equipment and making sure that it's suitable for that environment. In the North American world, I realize that many of you don't deal with the US installations, but we actually have in the United States a legacy class and division system. And we've also adopted within the National Electric Code, within NEC 505, which is basically our wiring regulations, we've adopted the zone concept. So a little bit of a comparison, if you will. Division 1 is an area in which a flammable gas exists under a normal operation. Division 2 exists under abnormal operations. So in generalities, a Division 1, if we look at Division 1 versus zones, Division 1 encompasses both a Zone 0 and a Zone 1 type environment in the international community. Division 2 is roughly the equivalent of Zone 2. Then we further subdivide under dust for Class 2 hazards, both Division 1 and Division 2. And again, those break down into either Zone 20, Zone 21, or Zone 22. And then also within the NEC, we actually have fibers and flyings as a Class 3 hazard. Again, Division 1, Division 2. In the international community, we throw those into our dust hazards as Zone 20, Zone 21, and Zone 22. So our definition, if you will, for zone applications is very similar to what the IEC follows: a continuous, normal, or abnormal operation.
Bob,
So, Paulo, I think we have our first poll question.
Sound is better now?
Yes.
You know, I did something earlier and I made you the host. I am no longer able to launch a poll. So you either make me co-host or you launch the poll on behalf of me.
I tell you what, I'll launch the poll. How's that?
When I click, instead of making you co-host, I made you host. So guys, here's a poll question for you guys. See if you have been listening to what Bob has been talking about. What would be the definition of a zone 1 hazardous environment per 6007910.1? Of course, it's a easy and not easy answer. There are some giveaway in the answers. See if you, we are not voting you, you know, we're not judging you, but please, I don't even see the result anymore. So well, I don't know if people are voting or not. You have, maybe while we wait for this, you can try to see if we can go back and say, make Paolo co-host. Place where a gas or vapor hazardous atmosphere is present frequently or is present occasionally, or where it's not present occasionally, but during normal operation, but it can occur infrequently, and where dust area is present. So there are some giveaway here, and some answers are wrong because of, you know, the giveaway. You just try to be careful. I have no idea. I cannot start the poll. No.
I understand. I'm trying to figure out how to make you a co-host.
You made me co-host. Thank you, Bob. Thank you. Now I can see the poll. Something happened, you know. So, all right,
we'll give it another few seconds.
Okay, guys. It's easy and not easy because the answer can be misleading, but basically, zone 1 is an area where you have frequently, or well, say, well, I don't want to say something that is misleading. You know, zone 0, you have constant presence, or most of the time. Zone 1 can be present during normal operation. Zone 2, only through a fault.
Right.
All right. I think, you know, our guys have answered correctly, right, Bob?
Yeah, for the most part, it is. So a continuous hazard would be considered to be a zone 0, right? And the correct answer in this case would be B, where a hazardous atmosphere is present occasionally during normal operation. Again, we expect to have a flammable gas air atmosphere present at some point in time, but it's not continuous. And then certainly answer C is not present occasionally, but it will occur infrequently. The answer with D is a little bit of a trick one. A dust hazard atmosphere present occasionally during normal operation. That's actually would be considered to be a zone 21 hazardous location as per 60079-10-2. So,
all right.
Good job. Good job. All right, so let's close that out and we'll continue on.
I'll let you work on it, Bob, and I still don't see the polls. I see the question and answer, guys. If you have any question, you can type in there, but you you run the polls, Bob, okay?
Okay, no worries.
Great.
So a little bit further about our wall chart. Within gas dust, we now need to subdivide these gases and dust. And we base that upon a couple factors: the minimum ignition energy, the MIE, the explosive pressures, the MESG, and the explosive ranges of various gases. The LEL is the lower explosive limit, and UEL is the upper explosive limit. MIE comes into play specifically when we're selecting intrinsically safe barriers. That's the minimal amount of energy that it takes to ignite a flammable gas air mixture. So the gases that are most difficult to deal with are basically the gases such as acetylene and hydrogen. And we put those gases, both from a North American standpoint as well as an international community, in pretty much a individual group. Most of the other gases and vapors will fall within other groups. But basically looking at the international side of things, again, if it's below ground, a group 1 hazard, that is methane that we would typically find in a coal mine. But anything from a surface area, we would put them either in a 2A, a 2B, or a 2C. So hydrogen and acetylene fall within 2C gas. Those are both 2C gases. Ethylene is a good example of a 2B gas, and propane is a good example of a 2A gas. So there used to be, and you will still find products that will be marked with just a Roman numeral. If it's marked with a Roman numeral 2, then it was implied that it was good for all gas groups. Now, the latest edition of the 60079 standards have insisted now that products that were previously marked as Roman numeral 2 shall be now marked Roman numeral 2C. So understand that gases get grouped into different groups based upon various factors. In the United States, we follow a similar concept, except the numbers don't, or the letters don't jive with the international community. Of course, we have to be a little bit different. Group A is considered to be acetylene. Group B is hydrogen. C and D gases are the very much most common gases that we're going to find in the process industry. So we won't talk about the dust so much, but it's the same concept. Now, the other thing that's important to understand is what is called ingress protection or IP code. Sometimes these are called international protection. But IP codes have to deal with a piece of equipment and suitability for an environmental condition. So there's 2 digits generally. Sometimes will actually be followed by a letter, but generally speaking, there'll be 2 digits. The first digit deals with a solid protection. So this could be dust, this could be objects, some sort of solid, if you will. The second digit applies to water ingress. So generally speaking, as we go up higher in the numbers, if you will, it's a higher level of protection. Generally speaking, EX equipment must maintain an IP54 or greater. So a lot of EX equipment that you will find out there will be dust tight, which they'll be IP6, and they'll also be suitable for direct water applications such as either jetting, powerful jetting, or temporary immersion. So 65, 66, 67, and in some cases 68. There is one little thing within IP codes that's important to note. IP66 is a more onerous test, the powerful jetting test, than actually IP67. So let's not make the assumption that a product that is IP67 is suitable for an IP66 application. So what manufacturers have actually done is, with regards to products that meet both of those applications, they will actually dual market with both IP66/67, because there is a little bit of confusion. Now, generally speaking, a higher IP code will always be suitable for a lower IP requirement. So if I have a piece of equipment that's IP65, it would be suitable for applications where I require IP54. So just like Roman numeral 2C gases is good for all gases, the same thing holds true in this case about high IP ratings. Oh, one last thing on this. North American, we follow what are called NEMA standards. Now, NEMA standards don't cross directly over to IP codes. They're similar, but they also include, in some cases, description about the type of protection. So, for example, a NEMA 7 enclosure is considered to be an explosion-proof box. So that has nothing really to do with the environmental protection. But NEMA 4, NEMA 4X is commonly what you might see with a lot of hazardous location equipment here in the United States. 4X is basically a corrosion version resistant product, very similar to NEMA 4. NEMA 4 is basically a hose directed water, very similar to IP66. But again, there is not a direct correlation between IP codes and NEMA codes. Now, the other thing we have to pay attention to is our temperature codes. And this is where it really gets confusing for a lot of people when they haven't seen this before. So in the United States, we have intermediate temperature codes, but we won't focus our attention on the intermediate codes. We're going to go over all the way over to the right-hand side and just look at T1 through T6. So basically, T6 references 85 degrees C, down what you see at the bottom. What that basically means is that if we have an environment in which T6 gases are present, what that means is that we have a gas there that's present that has an ignition temperature of something between 85 degrees C and 100 degrees C. If we have a T5 environment, that means we have a gas present that's somewhere between 100 degrees C and T4, which is 135 degrees C. So using T6 as an example, which is a very, very low temperature, the only product we could use for a T6 environment is a product that has a T6 rating. So what does that mean from a product standpoint? A product that has a T6 rating means that that product under its highest ambient in which it's suitable for will never exceed 85 degrees C under normal or fault conditions on its relevant surface, meaning that in effect, we can take a T6 product and put it into a T6 area. The same thing holds true if we have a T6 product. We can use that product in every area based upon its T code. So if we're working on a project in which the client, or maybe you've made the determination based upon the gases present, it's a T3 environment, we could use a product that's marked T6 or T5 or T4 or T3. What we couldn't do is use a T2 product in an environment which requires T3 or lower, if you will. So hopefully that makes sense. There's some examples of ignition temperatures, and this is where we use the ignition temperature of the gas as our determination for our T code. So you can see on there things like methane is very, very high. Hydrogen is about 560 degrees C. Propane's 450 degrees C. Those are the temperatures in which propane or some of those other gases will spontaneously ignite when exposed to those temperatures, as opposed to having some sort of arc or spark or something that is a catalyst that starts that explosion.
Okay, guys.
So we're going to do another question.
You need to run it.
Yep, no problem.
There's no direct correlation between the gas ignition temperature and, for example, hydrogen is second C, so very dangerous gas, but it takes a lot, 500 degrees plus to ignite, whereas other gases which can ignite very low temperature, but they require a lot of energy.
That's right.
So
Hydrogen.
guys, let's see if you've been listening in to Bob. What would be the T code for a product that has a maximum relevant surface temperature under normal and for condition of 125? A giveaway is a bit most commonly marked. You will see on a product. A barrier, for example, GMI barrier are certified for zone 2 installation also, and therefore have a marking.
Right.
The marking indicates how hot they can get under test, under full condition. And there's also some, if I remember correctly, there's some margin, you cannot reach. So I don't remember this. It says, 160, you cannot go at 159.9, there's some, I don't remember by standards, but anyhow. So it's a easy answer because it's the most common code you find out there.
Yeah, and just as a quick help here, right? Just to help you, T6 constitutes 85 degrees C, T5 is 100 degrees C, T4 is 135 degrees C, T3 is 200 degrees C, and T2 is 300 degrees C. So T codes are important to understand and remember if you can. Of course, your wall chart tells you this, but just in case you want to understand it better. So let's go ahead and end the polling and see how you guys did. So yes, the majority of you did get the correct answer, and the correct answer is T4. So remember what T4 is, it's 135 degrees C. That means if I have a product that during my testing under a normal or fault condition in its highest ambient, the relevant surface does not exceed 125 degrees C, which is below T4, that's the way we would mark our product. So the product would actually have a T4 rating on it, and that product would be then suitable for environments in which you require either a T4, T3, T2, or T1 gas groups, if you will, or ignition temperatures of gases. So we're below the ignition temperature of the gases of all T4, T3, T2, and T1 gases. So good job. Now, let me close that.
Let's move forward.
So the protection concepts, and we'll really focus our attention again on gas environments. So there are basically four main categories for gas vapor hazards and how we deal with them. So energy limitation on the left-hand side, that's really, again, the concept is really intrinsic safety. This is where we're limiting the amount of energy. We also have what is called non-sparking. So increased safety, which is considered to be EXE. We also have containment, and there are a couple different protection concepts such as flame-proof, powder-filled. So we're containing an explosion inside of some sort of housing, if you will. And then finally, a separation. Separation is basically removing, in effect, either the gas or vapor from any potential ignition source. And common one that we use is pressurization, or EXP. So we'll talk a little bit more about the protection concepts. There are a bunch of different protection concepts that we follow in the international community. They're referenced by specific 60079 standards, and they are suitable for different gas zones, if you will. So intrinsic safety, EXIA, is a two-fault condition product, meaning that it can fail and it has redundancy and it is suitable for zone 0 environments. So let's continue on. So energy limitation, intrinsic safety, is considered to be EXI. This limits the amount of energy to levels below the minimum ignition energy for the particular gas group environment. And within barriers, we actually have three ranges, if you will, based upon the fault tolerance. So if you've been part of some of our other webinars on talking about the fundamentals of intrinsic safety, an EXIA barrier, in effect, will have three Zener diodes. Two of them are for redundant applications. The difference between an EXIA barrier and an EXIB barrier is basically that extra Zener diode, if you will. So we have a little bit higher level of safety. So therefore, EXIA is suitable for zone 0 applications. Again, energy limitation. Now, increased safety is a concept that's been around quite some time. It was developed by the Germans. And this concept is basically saying, look, if we don't have any arcing or sparking going on inside of our enclosure, we eliminate that due to the design criteria of the terminals or whatever it is on the inside. Therefore, the enclosure does not need to be either flame-proof or pressurized or doing something like that. So we basically, this is a very common protection concept that's used, especially for termination boards, junction boxes. We find a lot of EXE switches that might actually, or EXD switches that'll have increased safety terminals, or we can find power supplies, relays in which the terminal blocks have sufficient spacing to not allow arcing and sparking. So there is a lesser form of this, which is called EXNA, which has now been changed to what is called EXEC. And that is the same concept. So we're basically removing any arcing or sparking from the hazardous environment. Now, containment is what many people are familiar with, is the flame-proof concept, where we basically assume we're going to have arcing and sparking components. Those gases and vapors are going to migrate at some point in time during normal atmospheric changes to the inside of an enclosure. When a contactor makes or breaks, we potentially could have an arc. If we have that proper mixture of fuel gas on the inside of that enclosure, we'll have a contained explosion. So that explosion shall be contained within inside that enclosure, and all of the hot flaming gases must be vented. and they must be cooled to make sure that they don't ignite the gas surrounding the enclosure. So those are typically done with flame paths or joints. So a flange type enclosure like what you see in the upper right hand corner is an example of an EXD box with a flange type design. The important thing to remember on EXD is that we need to take especially good care of all of the flame paths. And the flame paths are the flanges. They could be threaded joints, the thread entries, if you will, for any cable glands or stopping plugs. Those are all flame paths as well. So we need to make sure that we take very good care of them. One of the downsides of flame-proof is that we really cannot modify these products once they come out of the factory. So we cannot add additional entries, we cannot add additional components, generally speaking, with any of these products once they're certified and once they leave the factory. There are other concepts such as powder filled. There's also what is called enclosed break. And again, these are all examples of containing an explosion. Now, the other one is separation, and there are quite a few of these. The one that we most commonly look at, if you will, is pressurization, which is EXP. So the concept is here is that we pressurize the inside of an enclosure to a level that's just right above whatever the atmospheric pressure is, and we keep positive pressure so no gases during normal heating and cooling during the day will get onto the inside of the enclosure and potentially come into contact with any arcing or sparking devices. So it's a very effective means of protection. One of the drawbacks with EXP is that we do need to have typically a source of good clean air. And this is not always available in certain facilities. But if we have instrument air, we have clean air that's there, certainly it is a protection concept that can be used. Other concepts like this are encapsulation, where we basically take individual components such as a ballast or a relay and we encapsulate it with a resin. Again, we're removing the gas-air mixture from any arcing and sparking. There's oil immersion, which is commonly used for transformers. There's also what is called restricted breathing, which is commonly used for light fittings. So these are all separation concepts. Now, the EX markings, I'm going to skip this one right now because we're going to use an example of an EX marking here in just a second. So we'll kind of move forward from this slide and we'll go right to this one. Actually, let me go back. It probably makes sense to at least kind of reference this to show you a little bit about what we're looking at. So what we find here, here, and here is basically these are the requirements under the ATEX directive that we have to have an EX in a hexagon, a CE mark that's telling us it's compliant to the ATEX directive. This number applies to the notified body, which is basically the testing lab that did it. Remember, we talked about equipment group 2, that's for surface areas. Then we have our category 1G, which in effect 1G is telling us it's suitable for a zone 0 environment. Then we get into our marking strings over here. So we have our EX IA, which is intrinsic safety, double fault tolerant. It's good for all gas groups. It has a T4. And then finally, we find our IEC-EX EPL's GA. So this is a typical marking string that we would find on a piece of equipment. And then what you will also find, you should find information, the certificate number. So generally, we see the term ATEX within the certificate. That's a dead giveaway that it's telling us it has an ATEX certificate. And then we'll also find, in many cases, excuse me, an IEC-EX certificate as well. So that is what you would typically find with a lot of products. So using the example from GMI on a barrier, what we actually see here, this line, what you notice that we have a Roman numeral 2, 3, and we also have a 1 in a parentheses. So what this is telling us with our EX here and our CE mark and our Roman numeral 2, and category, it's telling us it has ATEX. And by the way, there's our little ATEX giveaway. But now we have this 1 in brackets and we have 3 here. The 3 is telling us in effect where we can install this product, meaning it's a category 3G, which is the equivalent for a zone 2 environment, which, understanding our protection concepts, EXNA is a protection concept that's suitable for zone 2. But then we see this IAGA in brackets. That in effect is telling us that it's providing downstream protection for a device that's located in a zone 0 environment. Then we have our gas groups, 2C, our T code, and our EPL markings as well. So this marking string actually has a couple different bits of information. Again, where it can be installed and what it can provide downstream protection. So let's clear that one, and then we'll look at another label. So this is an example of a label of a flame-proof enclosure. And how I know this is flame-proof? Well, let's see. I can show you a little bit here. Here's our protection concept, EXDB. So this would, the old legacy would be marked EXD, but that's now changed to DB. So here's our ATEX certificate, what you see here. We see our little CE mark here. We should find, and there it is, our little EX hexagon. This is telling us the notified body that did the test. So this is our ATEX marking string. We have surface area, category 2G and D, so it's good for zone 1 and zone 21 based upon both gas hazards and dust hazards. Our EX marking string, which is flame-proof. In this case, it's telling us it's good for 2B gases plus hydrogen. So it's not 2C, but it's 2B plus hydrogen. So in effect, this product was not able to pass the requirements for acetylene, but it did pass the requirements for hydrogen. Then we have a T code associated with it, T5, meaning that the relevant surface area for this product will never exceed 100 degrees C. And then finally, our EPLGB. So this happens to be our dust string, marking string, which we won't really cover. Then we have our IP codes. Notice we have both IP66 and 67. And this is important to understand as well. This product is suitable for an environment in which the ambient could range anywhere from -20 to +55. Now, when we look down here, we see there's our IEC EX certificate. This is our IEC EX string, which again is basically the same as what we find here. But under IEC EX, we do not put this information that we see over here. Again, same information for dust, same information for IP codes, same information for T codes or temperature ambience. So in effect, this product is certified both under the ATEX directive as well as IEC EX.
Bob.
Oh, and Paulo just circled the little X.
What does that X mean?
Yes, and that's a good question. So X is a very, very important thing that we should all look for. And what that means is that that product has what is called a condition for safe use. So if we find products, one of the most important things, we need to make sure that we pull the certificate. And that certificate, that IEC EX certificate, is actually located on the IEC EX website at iecex.com. We can pull this certificate, and on that certificate, it'll say something about what are the conditions for safe use. Now, the condition for safe use for this particular product could be, since this is a flame-proof product, it could state something to the effect of all glands must be installed in accordance to 60079-14, or it must be installed in a particular fashion, or what have you. So many times products will have X conditions, and as a inspector, when I go in and I take a look, that's one of the first things that I'm going to look for. I want to see the certificate, I want to see that X condition, and then I want to check the installation. Did the contractor install it in accordance to the conditions for safe use? One good example, cable glands. Cable glands will generally always have an X condition. That means that if you look up cable glands, any of their X condition, regardless of the brand, what it'll say something to the effect of suitable for fixed installations only, meaning that I cannot use that cable gland with, say, a portable tool. But there may be additional requirements, meaning that that gland also may have a requirement in which the cable must be clamped within 300 millimeters to meet a pull-out requirement. So if we go and install a bunch of glands and we don't pay attention to that X condition, and somebody like me walks out to that facility and sees all these glands that haven't been clamped within 300 millimeters, and it's stated that very clearly on their certificate, then that's a major issue. So always, always, always pay attention to the X condition.
Yeah. For example, in GMI,
glad you brought that up.
Typically, the GMI bearer would have an X certificate, an X at the end of in the certification, which, because they're designed for installation in zone 2, but they cannot be placed in zone 2 as is because they're IP20, IP54 is a minimum requirement. So the X would say, please install in a suitable enclosure, blah, 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 blah. So right. Yes, very important to look at the X, because it might limit your installation. And then, as you said, Bob, very clearly, when you go out to have an inspection, you're going to run into big troubles.
Right. Absolutely.
So here's the next poll. Again, Bob, you become so good. I will let you run this polls for.
Okay.
So this is a little tough, but it's not that difficult. What best answers describe the following EX marking string? Well, you can read it out. It's numeral Roman 2, parentheses 1, EXDB, square parentheses IA, numeral Roman 2C, second C, T6, GBGA. Some of these, are giveaway without knowing too much. You should be by now know what some of this number means. Of course, marking is the most difficult, even for me that I work in IS, I don't know, for as long as I can remember. But also you have marking from ATEX, ICX, then you have marking in Japan standard, US standard, everybody marks in different ways.
Right.
In fact, I wanted to mention to you earlier, Bob, that the example you're using of the label, a GMI label, it's a pretty old example. It's current, but is because today we have more certificate and you have no idea how many information we have on that label. They are unreadable.
Yeah.
New lines, So you pick a good one. So what is a flame-proof enclosure suitable for second C gases located in zone 1 that contains associated apparatus? Flame-proof enclosure suitable for second C gases located in zone 0. Flame-proof enclosure suitable for second C gases containing increased safety relays suitable for zone 0, or pressurized enclosure, blah, blah, blah. Well, I would say the last one there is, it's easy to see that this says pressurized. Pressurized is EXP.
That's right.
Yeah, I see an EXP here. I see an EXD. D is explosion proof or flame proof. So definitely one of the answer A, B, and C. There's also another giveaway, which is easy. We have parentheses. Bob earlier said that parentheses means something,
Yep.
Second certification. In this case, it means that it contains, right, Bob?
Yeah, so a couple giveaways here. Yeah, it is definitely a flame-proof enclosure, and the reason why we know that, we see the DB, but then we also see this IA in parentheses, and the IA is telling us that that enclosure is actually containing an associated apparatus, meaning that this, in effect, is a flame-proof box that contains intrinsically safe barriers that is providing protection downstream into a GA environment, which is a zone 0, but it can only be mounted in a zone 1 area. So if we think about all our questions, flame-proof enclosure 2C located in zone 1 containing associated apparatus, that would actually be the correct answer. So the other issues, the flame-proof enclosure is suitable for a 2C gases located in a zone 0 area. No, because this box is not suitable for zone 0. It would have to be marked DA, and we don't have that. Flame-proof enclosure containing increased safety relay suitable for zone 0. No, that's also not correct. So that's a very difficult one, but
Yeah,
you guys,
today the answer were a little, but only a few people got the right answer.
yep, and that's a tough one. That's a tough one, and especially going by memory, and you don't do it very often. So that's where your wall charts can actually really come into play.
I was gonna say, if you guys don't know the answer, just answer the first one. It's always the most.
Well, it's interesting. We actually we do kind of a look when we teach our complex courses, and we have some of the review of or the IECEX courses. A lot of times we find that actually the longest answer is many times it is the correct answer. So if you don't know the answer, if you sometimes just look for the longest one, and this is number A is one of the longest ones. So there you go.
So A was the right answer, guys.
A was the correct answer. So I'd be remiss to tell you also, besides just the EX wall chart, we also have a functional safety fundamentals wall chart, which we will not spend.
Close the poll, otherwise we keep seeing that.
Oh, I'm sorry. Stop share
All
results.
right. So yes, we do have a SIL wall chart, functional safety fundamental posters, as we have for EX. Both are available and they can be shared with you guys at any time. You just have to make a request for it. You can go online or use our. Let's go next. I think you have some.
Yep. Yeah.
Summary. Let's go for that first.
Yeah, just the important thing is just realize that wall charts do become out of date, right? And so always make sure you check your wall chart to make sure it's still up to date. If it's not, just reach out. There's a ton of really good wall charts that you can find online. Just make sure that they are up to date. And again, they're fantastic little tools. Hopefully they can make your life a lot easier. And again, we are only as strong as our weakest link. So our knowledge is really important, that we need to stay up to date with regards to standards, the rules and regulations, and understand it, because we are as strong as the weakest link.
Yeah, and on that, we are running several courses for functional safety and EX. Hopefully we'll come back to do these courses live one day. They are important, to be certified, to be knowledgeable. At the end, it's always people making mistakes. All right, Bob.
So
we have no questions so far, but we did have some questions through the registration process, which I will share with you guys. Let me the participants can share. I cannot, because
you can't.
I'm not the host anymore.
No worries.
Bob, see if you can. Sorry, I made a mistake earlier. I made you host instead of co-host. If you go there and make me co-host, I should be able to share my screen.
Well, let me just do this one. I'll how about I just put my screen up? How's that?
That's okay, but I did have one additional question that I put in the other night, which you will not have. But it's okay. We can answer that live.
Okay. Let me do this. I apologize. I have to do some rearranging here.
Sorry, you guys, you're still with us, right? We still have a few moments.
Yeah.
Yes,
okay.
You have to right click on my name and says allow to share, something like that.
Let's see.
Guys, I was in a Teams meeting right the moment before we start the webinar, so I was in a rush, and today I did things without thinking too much. Okay, now I'm okay. I can share screen. Thank you, Bob. Thanks a lot.
Sure. No problem.
Here we go. Share the screen. So hopefully you see it, right? Looks good.
I can see it.
First question. First question is, what EX concept would be recommended to use specifically for lightning or high power application, such as a switchgear? So Bob, you have prepared this answer.
Yeah. So increased safety with supplemental protection would make most sense with regards to, for example, on lighting. A lot of traditional lighting for zone 1 applications was basically flame proof. which were big, heavy cast type products. And then we started going to increase safety, which was the use of a lot of plastics. And now with the use of LEDs, they're encapsulating these LEDs. So this would be the most economical sense. When we get into switchgear, lower voltage up to 1,000 volts, usually flame proof or pressurization make really good sense. When we start getting above 1,000 volt AC, you're starting to get limited, but flame proof is still an option. We also would find in many cases, sometimes oil immersion for extreme applications, but generally speaking, flame proof, increased safety are the real common protection concepts for power applications, for higher power applications. IS would make the most sense for most applications involving low voltage or instrumentation circuits.
You cannot, energy limitation will not work when your energy that you need to use is, 1,000 volt. And all right. So next question: what is the difference between ATEX and ICEX approval? I can tell you that it's money. Cost. But
Money.
I'll let Bob answer this.
Yeah, no, and you're right. So ATEX is mandatory within the European Union, but you do find ATEX showing up in other parts of the world that people will say, I want ATEX, which is fine. IECEX is approved in other countries around the world, or is the basis for some of their own individual standards. So for example, if you go to Brazil, they have what are called the NBR standards, which are based upon the IEC standards. So getting Brazilian approval is, if you have an IECEX test report, it's basically a money issue, if you will. The standards themselves, if you will, under the ATEX directive, which is the requirements within Europe, you have to follow what are called EN standards. In the international world, you have to follow the IEC standards. The IEC standards and the EN standards, they are basically one and the same. The only differences are in the annexes that you will find within the EN versions that will reference other EN standards and certain stuff like that. But technically, they're the same. Zone 2 equipment under ATEX can be self-declared by the manufacturer. Under IECEX, this is not allowed. And as you can see, the marking strings, with the exception of category, the EX and CE marks and the EPLs are identical. So from a product standpoint, getting ATEX and IECEX, generally it's tested to really the same standards. You just, as Paulo said, have to spend a little money.
You will see that ATEX product carry ICX certification, or if you are getting ICX certification, you will extend to ATEX, because otherwise you cannot sell it in European market.
Right.
But they're very similar. So next question. Several types of EXE equipment must be housed in one enclosure for placement in zone 2. What kind of explosion protection on the enclosure should be? Now, okay, we have a similar question, but this is a little different. Let's see.
Yeah, so on EXE equipment, it's considered to be increased safety, which an enclosure is generally a sheet metal box. So if we had an explosion on the inside of a sheet metal box, it wouldn't contain it, right? So the equipment that we put inside must be EX certified in and of itself. So what you see there on the right-hand side is that you'll see things like power supplies or relays or barriers or various other components that will have, in many cases, their own certification. So generally, when we're talking about EXE type construction, the individual components that we put on the inside of that enclosure must all be certified. So that's one benefit by going with EXD, is that we can use within EXD general purpose equipment that we can put them in a hazardous location. If we go with EXE, then we have to make sure that all of those individual components have their own EX certification.
And as I said, Bob, we have a similar question which I've added. It was received late yesterday. Can a general purpose junction box be used as part of an IS loop? I know you provided an answer, Bob, but it was, 20 pages long. I tried to.
It was War and Peace. Yeah.
No, but basically, I guess my answer is yes or no. I don't know. There is depends.
That is correct. So, and it's a good question. It comes up a lot. So, what is the requirement? The installation design standard is 60079-14. And in 16.5, talking about terminal box. So, it basically what that is all saying right there in verbiage is that if we have a single circuit IS junction box, meaning that we've only got a single circuit. That enclosure does not require an EX certification, but it must maintain IP54 and it must be marked that it contains an IS circuit. The moment that we add additional circuits into that enclosure, either IS or non-IS, that box in effect would have to be certified. So generally speaking, what people do for more than one circuit, they'll use an EXE type enclosure with increased safety terminals. Typically, they might use blue terminals to indicate IS. And then again, we have to put a label on that box to say intrinsically safe circuits on the inside.
When you're talking about more than one circuit, you're talking about also two IS circuit or?
Yes. Yeah. So if you had just say a single switch, right, in a hazardous location, and it was coming back to a junction box, we just have one loop and it's going into that junction box, and then that junction box is carrying that circuit back to our control panel where the associated apparatus is. That junction box for that single loop is not required to be EX. Now, if we take a dual channel barrier and we have two circuits coming into a junction box, and then from that junction box, we branch off one way to one device and then to another device, at that point, that box would actually have to be certified.
Okay, that's very clear. So, question, does humid and corrosive environment affect EX equipment? I'm sure that it does. And here's your answer, some pictures you've taken through your inspection, right, Bob?
Yeah, yeah, I mean, absolutely. You have to take into account the environmental condition and where you're going to be placing the EX equipment. So the picture in the middle, that's actually a zone 1 area, and that's a motor. And that motor was only there, it had only been there for about 2 years. So you can see corrosion can be extremely devastating to EX equipment. Obviously, making sure on the example on the left-hand side where a light fitting obviously was leaking or something happened. So we had some corrosion on the inside there. The picture on the right-hand side is a nickel-plated brass gland, or actually, I don't know if it was nickel-plated or not, going into an aluminum enclosure, and you can see that you had some serious chalking, if you will. And this is a big issue with cable glands going into aluminum enclosures in a high saltwater environment. So you can start to see degradation very quickly if we don't provide suitable protection, either thread lubricants or using dissimilar metals or doing metals that are really suitable for the environment. So we have to take all that into account as well.
All right, guys, we have run over our time, but there's a few more quick slides. And we thank you. I see you're still all here. You've been quiet today. We have had no live question, but that is okay. So how can we get a copy of this GM wallchart? Well, please drop us a note. We will send you a copy of the presentation after the webinar, so you have our contact details. We also run many webinars, and all the time we get questions about this or that webinars. Well, you can go live to, you can go on our website to see our live webinar section, or on our YouTube channel to see all the webinars we run today. Well, the last 6 months. And, okay, so we come to the end of our presentation. Again, Bob, you're always on top. Today, you were not challenged as much as the other days, but that's okay. Guys, why don't you rate Bob performance today? Let's see if you, well, again, maybe better. Oh, I can run the poll now. Oh, I see.
Can you run the poll?
Yeah, launch it. Okay, you made me a master again. Okay, how did we do? Guys, keep in mind that, as I said, the webinars are recorded, so you can go back and view it again, and we will send you a copy of the slides. Bob, thank you.
Thank you.
And now is your, your day starts, right?
Yeah, it's 5:10 in the morning, so it's going to be a beautiful day. And by the way, we had our first taste of fall, so we had a cold front come through, so it's a little bit of crisp in the air, which is really nice. So I'll go outside, watch the sun come up, have my cup of coffee, and enjoy the early morning.
Great, great. I am in the afternoon. It's 38 degrees here.
Go.
So it's not nice to go out. Okay. And the poll you guys share. So we did good. Thank you guys. And Bob is, we have somebody talking about you and says, you're number one and you are number one. Thank you, Bob, again. Thank you, everybody. Thank you for being with us. I will see you soon. Ciao.
Ciao, everybody.
I'm the one that can shut it down. I cannot do it anymore. So you're in control.
Oh.